All right, good morning, everybody. All right, so last time we were talking about the motion of the sun around the celestial sphere and how that relates to the seasons. This time we're going to talk about the moon. Um, and there's a few things to consider here. Uh, the first thing to notice is, the moon goes through phases, right? We've all noticed that, one assumes. Um, The moon is sometimes big and well illuminated and full, sometimes it's a crescent, sometimes it's a gibbous. Um, so the moon is constantly changing, right? Every night the moon it looks a little bit different. But look at these pictures of the moon, right? Notice that the same pattern of light and dark areas looks the same every night, right? Those two dark areas, what are called Maria, the dark areas are called Maria on the moon. Right? The pattern, the features that you see on the moon are the same every night. Sometimes the moon is more illuminated and sometimes it's less illuminated, but the same face of the moon is always facing us. The same side of the moon is always facing the Earth. And so that generates a question. What does that imply? What does it imply if the same half of the moon is always facing us? Does that mean that the moon isn't spinning? Does that mean that the moon is not rotating? Let's think about this. Uh, little simulation here for us. All right, so here we are. We're looking down at the Earth and the moon from above the North Pole, right? There's the North Pole right there, right? There's North America, there's Asia. So here we are looking down at the solar system from north. All right. And let's say we paint half of the moon red. All right. If the moon weren't rotating, the red side would always be facing to the right. And that would mean that during half of the month, we would see the moon, here on Earth. If the moon didn't rotate, then at some point during the orbit, us here on the Earth would look at the moon and we would see the red side. Half an orbit later, we would be looking at the moon and we would see the white side. Right? If the moon weren't rotating, then we would see all sides of the moon at some point during the month. Right? Right? We would see the red side during half of the month and the white side during the other half of the month. If the moon were rotating really quickly, then the moon would be spinning, 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 and we would see all sides of the moon multiple times per orbit. Right? So if the moon doesn't rotate, we see all sides of the moon. If the moon rotates fast, we see all sides of the moon. What's actually happening is the moon is rotating, but it's rotating slowly. The moon is rotating at the exact same rate that the moon is orbiting around the Earth, such that the red side of the moon is always angled down toward the Earth. Right? The moon is rotating in the same amount of time as the moon revolves around the Earth. Right? Like this. This is what's called synchronous orbit or synchronous rotation, right? The rotation and the revolution of the moon are synchronized such that one half of the moon is always facing toward the Earth and one half of the moon is always facing away from the Earth. Right? The rotational period and the period of revolution are the same. Meaning what? What is period? When I say period, what I mean is the time for it to make one rotation and the time for it to make one revolution around the Earth are the same, such that the moon is constantly rotating so that one half of the moon is always angled toward the Earth and the other half always angled away from the Earth. That's how you can explain why we always see the same face of the moon. All right? We talked last time, when talking about the sun, about how the Earth orbits the sun counterclockwise. The Earth also, here again, we're looking down at the Earth and the moon from north. The Earth also rotates counterclockwise, and the moon orbits the Earth counterclockwise. This is not a coincidence, right? The way that our solar system formed, right? At the very beginning, when our solar system started to form, everything was spinning counterclockwise. And therefore, as everything coalesced, as the planets and the moon and the sun, as everything formed, they just kept on going counterclockwise. And consequently, almost everything in our solar system, with a few exceptions, but almost everything in our solar system is still going counterclockwise. Right? It takes the moon 27.3 days to orbit around the Earth one time. To make one full 360-degree orbit around the Earth has a period, the moon has a period of 27.3 days. This is what's called a sidereal month. What does that mean? Well, the word sidereal means relative to the stars. So if there's a star, back here, let's say, where my mouse is at here, right? If there's a star back here, then at the beginning of the month, the moon lines up with that star. The moon makes one 360-degree orbit around the Earth, and you know that the moon has finished a full orbit when it lines up in front of that star again. So that is a sidereal month. The moon has made one circle around the Earth relative to the background stars, right? Because the stars aren't moving, right? The stars are always at fixed right ascensions and declinations. The stars are always in fixed positions on the celestial sphere, so they make good fixed points by which to measure the motion of things like the sun and the moon around the ecliptic. All right? So, how do we understand the phases of the moon? All right? Well, if we're looking down at the Earth and the moon and the sun, notice how much of the moon is illuminated. Well, it's always half, right? The half of the moon that's facing the sun is illuminated. It's in daylight, right? Half of the moon is always in daylight, half of the moon is always nighttime. It just, depends on which half is facing the sun and facing away from the sun for nighttime. Right? But, right, the moon is always half illuminated, just like the Earth is always half illuminated by the sun. But that's not what we see, because we're always here on Earth looking out at the moon. So during certain times of the month, during certain times of the moon's orbit, we're on the Earth looking at the moon, and what we see is the nighttime side, because the daytime side is facing away from the Earth. A couple weeks later, now we're on the Earth looking at the moon, and what we're looking at is the daytime side. And the nighttime side is facing away from the Earth, right? The same side of the moon is always facing the Earth, right? The near side, we'll call that the near side of the moon. When, to go back to my little cartoon here, right? Let's call the red side, right? Let's call the side that's always angled toward the Earth, we're going to call that the near side of the moon, right? The side that is nearer the Earth, because it's always pointing down toward the Earth. The far side of the moon will be the side that's always facing away from the Earth. And we can't see the far side of the moon from the Earth because it's always facing away from the Earth. All right? The reason why the moon goes through phases is because the side that is being illuminated, the side of the moon that's being illuminated by the sun, is not always the near side. Sometimes it's the far side. Sometimes it's half and half. All right? So let's go through these phases of the moon. Let's go through them step by step, and we can see if this makes a little more sense. By tradition, we start the lunar month with the new moon. Right? The new moon is the one where the near side of the moon is in darkness, right? The far side of the moon is being lit up by the sun. The side that we can see is not being illuminated by the sun. It's nighttime on that side of the moon. It's nighttime on the near side of the moon. And therefore, from Earth's point of view, when you're looking at the moon, you see the moon is dark. Does that mean you can't see the moon? Sometimes, right? Sometimes you just can't find the moon that night. Well, I should say, you can't find the moon that day, because if the moon is right here in its orbit, then the moon is in front of the sun. So when is the new moon in the sky? If the new moon is in front of the sun, the new moon is up during daytime. So you're not going to see the moon at night. Right? So that's one of the big reasons why it's hard to see the new moon, is it's up during daytime. Sometimes you can still see the new moon. If it's a clear day, if you've got a nice clear blue sky, and if you've got a good idea where to look, and if you've got something that you can cover up the sun with, like, block the sun with your hand, and if you know where to look, you can still see the dark moon. You can still see it. It's a little different shade of blue against a blue sky. So the new moon is not completely invisible. It's just harder to see. You got to kind of know what to look for. Here we're going to get into a little bit of vocabulary, right? The phases of the moon are all about how the near side of the moon is illuminated, right? How the side of the moon that we can see from here on Earth is illuminated. When the near side of the moon is less than half illuminated, that's called a crescent moon. When the near side of the moon is half illuminated and half in darkness, that's called a quarter moon. Why is it called a quarter moon? Shouldn't it be called a half moon? We'll get there in a second. When the near side of the moon is more than half illuminated, it's called a gibbous moon. And then when the near side is fully illuminated, that's a full moon, which you're probably familiar with. All right, so let's see how this all plays out. Oh, oops, got ahead of myself. A couple more pieces of vocabulary. When the moon is getting brighter from day to day, the moon is said to be waxing. So when you go from crescent to quarter to gibbous to full, the moon is getting brighter, 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 full, right? That the moon is said to be waxing. When the moon is getting darker from day to day to day, when you're going from a full moon and then the moon is getting darker, 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 and then you have the next new moon, the moon is said to be waning. All right, so waxing means it's getting brighter day by day. Waning means it's getting darker day by day. All right, okay. Now let's see how this all plays out. Okay, you start the lunar month with the new moon. About a week later, a few days later, not a week yet. A few days later, the moon is orbiting around the Earth counterclockwise. Now the moon is here. Now, imagine you're looking at the near side of the moon, right? You can only see the near half of the moon. The left side of the moon is fully in darkness. The right side of the near side is a little bit illuminated. So you have the left side is dark. You're getting a sliver of light on the right side. That is a crescent. And it's getting brighter, so it's a waxing crescent. All right. A week after we started, now the moon is a quarter of the way around the Earth. And now the left side of the moon is in darkness. The right side of the moon is bright. It's a first quarter. This is why it's called a quarter moon, because the moon is the moon has gone the first quarter of the way around the Earth. All right, and then the moon keeps on going. A few days after that, now the moon's over here. Now the right side of the moon is all lit up, and you're just getting a little sliver of darkness on the left side. Sliver of dark on the left side, all bright on the right side. That is a waxing gibbous, right? Gibbous because it's more than half illuminated. Waxing because it's still getting brighter. It's on its way to a full moon, right? When the moon is on the opposite side of the Earth from the sun, then the near side is fully being illuminated by sunlight. You got a full moon. All right? And then the moon keeps on going. And then, how much time does it take to go from new moon to a full moon? About 2 weeks. And the moon keeps on going. Now the moon's going to start getting darker, right? We've gone past the full moon, and now the moon's on its way to going to the next new moon. The moon's going to start getting darker. So now what do we see on Earth? Well, the left side of the moon is all bright, and there's a little sliver of darkness on the right side, sliver of dark on the right, bright on the left. It is a gibbous, but it's getting darker now, so it's a waning gibbous. 3 weeks after we started, now the moon has gone 3/4 of the way around the Earth, so this is a third quarter moon, where it's dark on the right and bright on the left. A few days later, now we're getting close to the next new moon. The moon's getting darker, darker, darker. It's waning. There's just a little sliver of light. The far side of the moon is getting most of the sun's illumination. There's a sliver of light on the left, and the moon is otherwise dark on the right. It is a waning crescent. And then 29.5 days after we started, the moon is the next new moon. The moon hits the next new moon. We have gone through one cycle of the moon's phases, from new moon to the next new moon. Wait a minute, Brian. Didn't you say that one orbit of the moon was 27 days? Why are you saying it's 29 days now? Well, what did I say? 27 days is how much time it takes for the moon to orbit the Earth one time, 360 degrees. But in order for the moon to go through a cycle of its phases, right? When you go from new moon to new moon, let's say we start right here. The Earth is right here. The moon is in front of the sun. It's a new moon. In order for the moon to go around the Earth, that takes a month. Well, in that 1 month, the Earth has also moved 1/4 of the way in its orbit around the sun. Which means, let's say there's a star way off over here. Let's say there's a star way, way, way off on the right side, right? The moon is in front of that star and also in front of the sun. If the moon goes around the Earth and comes back here, right here, the moon is now back in front of that star again. It has been one sidereal month, 27 days, but the moon's not new. The moon is still a waning crescent. The moon needs to move another 2 days in order for the moon to line up in front of the sun again to be the next new moon. Because in that month the Earth has moved around the sun, it takes the moon a little longer. It takes the moon 2 more days to line up in front of the sun in order for the moon to complete its cycle of phases. That takes 27.5 days. So consequently, there are 2 kinds of months. Right? There is a sidereal month, which is where you're tracking the motion of the moon relative to the stars. And then there is a synodic month where you're tracking the motion of the moon relative to the sun. Right? And if you're tracking the moon relative to the sun, then it takes a synodic month for the moon to go through its full cycle of phases, from new moon to the next new moon. All right? Okay. That's why the moon changes its appearance. Right? The phases of the moon and the motion of the moon relative to the sun is also what gives rise to the eclipses. So let's talk about eclipses for a second here. Eclipses happen when the Earth, the moon, and the sun line up together. All right? Because when the Earth, the moon, and the sun line up together perfectly, the shadow of one strikes the other, and that's what causes an eclipse. So, which is it? When the moon's shadow, right, when the moon goes in front of the sun, and the moon's shadow hits your location on the Earth, is that a solar eclipse or a lunar eclipse? When the moon covers up the sun, that's a solar eclipse. Right? When the moon passes into the Earth's shadow, right? The sun is shining on the Earth, the Earth is casting a shadow into space. When the moon passes through the Earth's shadow and the moon gets dark, that is a lunar eclipse. All right. Also, what phase is the moon in during what phase is the moon in during a solar eclipse? Right here. When the moon's in front of the sun. You got the Earth, you got the moon right here, you got the sun. What phase is the moon in? It's a new moon, right? So a solar eclipse always happens during a new moon. Over here, where the moon is on the opposite side of the Earth from the sun, and the moon is passing into the Earth's shadow, you get a lunar eclipse. What phase is the moon in now? Well, if the moon is on the opposite side of the Earth from the sun, that's a full moon. So lunar eclipses always happen during a full moon. But you're probably thinking now, but then why don't lunar eclipses always happen during a full moon? Why don't solar eclipses always happen during a new moon? What's going on there? Well, new moons and full moons happen every month, but you don't have eclipses happening every month. Why? Well, we need to think about this three-dimensionally. All right, here's a bit of a diagram. Here's the sun, here's the Earth. This blue path here is the path of the Earth orbiting around the sun, right? In other words, this is the ecliptic, right? This is the ecliptic plane. Here's the moon orbiting around the Earth. What you notice is, right, that blue disk is the plane of the Earth's orbit around the sun. The yellow plane is the plane of the moon's orbit around the Earth. They don't line up perfectly. The moon's orbit around the Earth is at an angle to the Earth's orbit around the sun. During half of the month, the moon is north of the ecliptic. Right? What is the ecliptic? We said last time, the ecliptic is the sun's path around the celestial sphere. Sure. But why does the sun take that path? The sun takes that path. The sun takes this path around the sky because that's the direction that the Earth orbits the sun. Right? If you were looking at this plane, this is the ecliptic. Here the moon is north of the ecliptic. Here the moon is south of the ecliptic. The moon spins half the month a little north of the ecliptic by a few degrees, right? The moon's orbit around the Earth is only tilted a few degrees with respect to the Earth's orbit around the sun, which means the moon gets a few degrees north of the ecliptic over here and a few degrees south of the ecliptic over here. What does that have to do with eclipses? Well, most of the time, the moon is not right on the ecliptic. It's not right in line. Most of the time, the moon is not right lined up with the Earth's orbit around the sun. So let's say right here, right? Right here, the moon is on the opposite. Is that better? Okay. Right here, if you were on Earth looking at the moon, what would it look like? You'd see the near side of the moon fully illuminated. What phase is that? It's a full moon, right? On Earth, you would see a full moon, but it's not a lunar eclipse. Why not? Because the Earth's shadow is going off in this direction, right? The sun is over here, casting the Earth's shadow in this direction. The moon is north of the ecliptic, and that means the moon is north of the Earth's shadow. The Earth's shadow doesn't hit the moon, not an eclipse. It's just a normal, everyday, or every month. It's a normal, every month full moon. A couple weeks later, now right now, if you're on the Earth looking at the moon, the near side of the moon is dark. It's a normal new moon. but it's not a solar eclipse because the moon's shadow is shooting off down here somewhere. And if the moon's shadow doesn't hit the Earth, it's not a solar eclipse, right? Most months, the new and the full moons happen when the moon is not perfectly lined up with the ecliptic. Now, right here, the moon is on the ecliptic, right? The moon, the Earth, and the sun are all in the same plane, except you don't see an eclipse. Why? Because it's a third quarter, right? The moon, if you were on the Earth looking at the moon, you would see pretty close to a third quarter. Maybe a waning crescent or a waning gibbous, maybe, but pretty close to third quarter, right? But, oh, here we go. All right, now, oh, closer, closer, closer. Boom. Right? There's your lunar eclipse. All right? It's a full moon. The moon is opposite the sun. And the moon is not north of the ecliptic, not south of the ecliptic. The moon is right on the ecliptic. The moon is right lined up with the Earth's orbit around the sun, and therefore the Earth's shadow is cast on the moon. You have a lunar eclipse. And notice what happens next. 2 weeks later, oops, got this wrong. Here we go. Right? 2 weeks before this, 2 weeks before that, we don't see the shadow, so this is not a perfect diagram, but 2 weeks before that, you have a solar eclipse, right? The sun's over here, the sunlight hits the moon's shadow is cast on the Earth, you would see a solar eclipse. Why is there a solar eclipse? Because the moon's in front of the sun, it's a new moon, and the moon is lined up right with the sun. The moon is on the ecliptic, directly in front of the sun, blocking the sun, causing a solar eclipse. This always happens. Eclipses always come in pairs. You always get a solar eclipse, and then 2 weeks later, a lunar eclipse. Or sometimes it's vice versa. Sometimes it's a lunar eclipse and then a solar eclipse. But they always come in pairs. Right? This is what causes the eclipses. Right? The moon hits the ecliptic every month, but not always during a new or a full moon. The moon is a new moon and a full moon every month, but not always when the moon is on the ecliptic. In order to have eclipses, you need both. In order to have an eclipse, you need to have you need the moon to be in a new phase or a full phase, and the moon needs to be right lined up with the Earth's orbit of the sun in order for the shadow of one to hit the other, and then you see the eclipses. All right? That's how the phases of the moon correlate to eclipses. This is why you don't see eclipses every month. You see the phases of the moon every month, but you don't see an eclipse every month. How often do eclipses happen? They usually happen a couple times a year. Right? Eclipses are actually fairly common. You'll have two pairs of eclipses, right? Because a lunar eclipse and a solar eclipse always go together 2 weeks apart. But yeah, you'll have a pair of eclipses. Usually it's twice a year. Some years there's only one pair, but it's usually about twice a year. Why don't you see eclipse? Why don't you, specifically you, why don't you see eclipses twice a year? Well, they may not be happening in your part of the world, right? In order to see a solar eclipse, let's say right here, right? In order to see a solar eclipse, the moon's shadow needs to hit your location on the Earth, which, that only happens. The moon's shadow only hits a specific location on the Earth. It's every few years. The moon's shadow hits somewhere on the Earth about every 6 months. but it may not be where you are. Why don't you see a lunar eclipse every 6 months? Sometimes it happens. Sometimes the eclipse happens when the moon's not up in your sky. Or maybe it just happens really, really early in the morning and you're not up to see it, which is usually my luck. Right? If you're in the right place at the right time, you can see the eclipses. If you're not in a part of the world where it's the right place, right time, you'll usually see an eclipse every couple years. Or you got to travel. Some people make a hobby out of traveling around the world, so that they're in the right place at the right time to see solar eclipses, which is a fun hobby if you've got the time and the money. There are worse ways to spend your life. Uh, all right. I hope that makes some sense. You'll get some more practice with the homework and the labs, and then we'll talk about the celestial sphere and the constellations a little more next. All right. Bye.